So this will just be a short video on an application of uniform circular motion, that is banked curves. So from the SACE learning intentions, on a flat curve, the friction force between tyres and the road causes a centripetal acceleration. So to improve safety, some roads are banked at an angle, and I'll show you what I mean by that. So banked at an angle, so the road is banked at an angle, and that's to improve safety, and I'll show you how in a minute. So you need to do these following two dot points, which I'll go through on the next slides. So you need to be able to draw a diagram showing the force vectors for a vehicle travelling around a flat curve. So when a car is travelling on a flat road, there are several forces acting. So obviously there is the weight of the car, and the weight of the car is mass times the gravity. That's acting directly downwards. Now a weight force, because forces occur in that have an equal and opposite force, now there is a force called a normal force. So hopefully you're familiar with normal forces. Now normal forces act perpendicular to a surface. So the normal force is distributed between the car tyres. So that normal force is acting straight up to balance the weight force. Now, there are frictional forces between the tyres and the road, and that's what provides the centripetal force and uniform circular motion. And there's obviously a driving force or a thrust force, and that pushes the car forwards. So for a car to move in a uniform circular motion, a centripetal force is required between the tyres and the road, and that's actually so this has a limiting value, so if the car is moving too fast, eventually the car will not be able to remain within the circular path. But anyway, it's the tyres that provide the centripetal force and acceleration for undergoing uniform circular motion, which is a turn at a constant speed. Now, if you bank the road, so you need to be able to draw a diagram showing the force vectors and their components for a vehicle travelling around a banked curve. So this is a banked curve. So if you bank the road, make the road on an angle, the banked curve will cause the car's normal force. So remember, normal force always acts perpendicularly to a surface. So this is the surface of the road. The normal force is perpendicular at a right angle to the surface. So that's our normal force now. Now the normal force actually is going to have a horizontal component of normal force and a vertical component of normal force. Now the vertical component of the normal force counteracts with the gravitational force, and that doesn't affect the motion of the vehicle. But by banking the curve, this horizontal component of normal force is super vital, because this horizontal component of normal force is actually acting towards the center of the car's path. And this force here, so the horizontal component of normal force, provides a centripetal acceleration necessary for the car to travel with uniform circular motion and hence go around the bend at a constant speed. So the force provided by the horizontal component of normal force that is provided by the banked curve actually reduces a car's reliance on friction to make a safe turn. So by banking the curve, we're able to actually travel around corners faster because we less rely on the friction between the tyres. And if you've ever seen bobsledding down in the Winter Olympics, those bobsleds are travelling so fast, and if you notice, the track is always banked at an angle, so that the bobsled, because there's very minimal friction, but by banking the corners, the bobsled is able to have enough centripetal force and centripetal acceleration to go around those curves at a constant velocity. So there used to be a lot in the course on this, so for some reason this textbook kept a lot of old questions that aren't relevant for you. You only need to do question 11, 18A and B. Skip all the rest, they're not part of the course anymore, even though the textbook still has them in there. Alright, cheers.